INDAG has more than 70 years experience in inline mixing processes. About 15 years ago, we developed this high-pressure inline mixer pushed by customers asking us all time to make machines for high pressure, high temperature. Now we made it, and it's proven technology. With all our experience in inline mixing, we know that this machine works for your challenging mixing application. So please ask us to help in your mixing goal. In standard, we deliver these machines starting at 50 kg an hour, rather for compounding lines. For polymerization, we start at 500 kg an hour and go up in standard in more than 10 tons. And we already delivered for special executions mixers for way more than this. Our high-pressure inline mixers are made in different pressure stages. This one here is for 200 bar design pressure. In standard, we have mixers for 40 bar, 100 bar, 160 bar, and higher on request, as this one here for 200 bar. The system pressure has high influence on the mixer design, especially on the bearing block and the bearings inside, as well, of course, of the casing and the size of the bolts and the flanges. If lower the pressure, if lower the design pressure, if more compact the machine can be, and finally for the customer, more cost efficient. We do have customers for polyamide and polyester applications who running this machine continuously 24/7, 365 days a year without any stop for years, 2 or 3 years without any maintenance. A real reliable system, heavy duty, engineered here in the north of Germany. The huge advantage of this mixer is to make an absolutely homogeneous mixture within seconds. This machine here for 10 tons, the mixing time of somewhere around 4 to 10 seconds mixing time is making in this short term an absolute homogeneous mixture with relatively low shear, no stress on the product, and keep the full function of the polymer and still improves it by adding additives. The huge advantage of a dynamic inline mixer over static mixer is it's dynamic. So means with help of the drive, you can have direct influence on the product and the process itself. Even by high variations in flow, you're able to ramp up and down the rotational speed of the rotor, as well as different recipes where you're adding different type of additives. You are fast in changing this product. The advantages over an extruder are significant, mainly the costs. An extruder for 10 tons wouldn't fit in this video here, but still this machine, small, compact, for a high capacity and doing the same job than an extruder when it's only about mixing. Of course, the machine can't melt, but in this case, it's not necessary. The melt is coming from the reaction process. Color master batch, in this case, carbon black, is added by a side extruder, simple one, very cost efficient. So this machine is doing the job previously a twin screw extruder with all the costs we're doing. We are here more efficient in the investment costs, space saving, way less energy consumption than any extruder, and finally the maintenance costs. The maintenance costs here are very low. We're talking about a rotor stator system which is not in contact, so there is no wear on the rotor and stator. They are stable for the whole life of the machine. The only wear part is here for the dynamic seal, stuffing box rings, thread shaft seal, as well, of course, as static gaskets. But this is just a minor thing in opposite to a rotor of an extruder or even a twin screw extruder. The calculation to design the mixer's size, the mixer length, and as well the rotational speed of the mixer based on experience we were collecting over all these years. Inline mixing is rather an empiric science, so fixed values for calculations not existing. Even though we worked together with different universities, but it's still state of the art that empiric values and trials are decisive for the calculation of a machine size. We do have knowledge on which mixer size for which kind of polymer at which application works. Based on this experience, tables, databases INDAG has, we design the mixer sizes. Even when there is something completely new for us, and we have no database for this, which is quite rare, we do in trials with a small inline mixer. This is the INDAG high-pressure inline mixer for laboratory and pilot applications. The capacity range is somewhere between 10 kg an hour to 100 kg an hour, depending, of course, on the application. For higher viscosities, we're running less capacity. For lower viscosity, of course, the higher capacities. The mixer can run up to 100 bar design pressure and temperatures more than 300 degrees Celsius. INDAG provides the suitable flanges here for the customer tri-run. Machine is equipped with a strong drive, frequency converter to ramp up, down the rotational speed for the tri-runs. With more than 70 years in experience of inline mixing applications, INDAG has a huge database of successful applications we're running. In case and every day new application come to our table, and if there is something absolutely new, we are able to run tri-runs with such a small unit and low quantities. For the quality check, we are heating up the mixer on the process temperature. In this case, it is 300 degrees Celsius to look for the heat extension of the casing and, of course, of the function of the dynamic seal and of the mixer itself. To heat it up, we are using thermal oil, or in process, the mixer can even be heated up by steam, by HTM steam. The mixer has two different heating zones, one for the mixing zone, one for the inlet zone, and at least one for the dynamic seal. In this case, we are using standard flanges for oil or even for the steam. In standard, the double jacket is able to withstand up to 6 bar in pressure and 330 degrees of thermal oil temperature. To show how easy the rotor rotates even now under temperature, we dismounted in this case the fan cover to show how I'm rotating and see the easy movement of the elements. By human power, it's easy to rotate the rotor. During the FAT, we are not only measuring the dimensioning and heat extension, as well we are proving noise pollution, as well as vibration, and as well all the function of the mixer.